Relation and functions. Relation and functions, an ordered pair is represented as input and output. The relation shows the relationship between input and output, whereas a function is a relation which derives one output for each given input. Note, all functions are relations, but not all relations are functions. So, what is a function? A function is a relation which describes that there shall be only one output for each given input, or we can say that a special kind of relation. A set of ordered pairs, which follows a rule, every x value should be associated with only one y value is called a function. Function, domain. It is a collection of the first values in the ordered pairs, set of all input x values, range. It is a collection of the second values in the ordered pairs, set of all output y values. For example, in the relation -2 and 3, 4 and 5, 6 and -5, the domain is -2, 4, 6, and the range is -5, 3, 5. So what is the relation? The relation between the two sets is defined as the collection of the ordered pair, in which the ordered pair is formed by the object from each set. So let's practice. Determine if the relation is a function. Letter A, 1 and 4, -2 and 0, 3 and -6. Letter B, -2 and 1, 0 and 5, 3 and 2, 0 and -1. So this is the answer. Letter A, domain -2, 1, 3, range -6, 0, 4. So therefore, it is a function. Letter B, domain -2, 0, 3, range -1, 1, 2, 5. So therefore, it is not a function because the ordered pair of two zeros. Letter B, determine if each graph shown below represent a function. Answer. Number 1. Yes, it is a function because when we put the vertical line in the graph, it only touches once. Number 2. No, it is not a function, it is a relation because when we put the vertical line on the graph, it touches it 3 times. Number 3. No, it is not a function, it is a relation because when we put the vertical line on the graph, it touches it 2 times.
Types of functions. Before we list down all the types of functions, let's go ask ourselves, what is a function? Function is a relation in which element of the domain corresponds to exactly one element of the range. So these are types of functions: constant function, linear function, quadratic function, rational function, power function, absolute value function, polynomial function, greatest integer function, piecewise function, and lastly, radical function. Now, let's go on to the first part. So our first type of function is constant function. A constant function is a function that has the same output value for every input value. Like this equation, fx equals to c, and c is not equal to 0. So that means fx equals to c, and where c is a constant value, then that means fx equals to 0. Here's an example, fx is equal to 10. So let's go on our second type of function, linear function. Linear function is defined as a function that has either one or two variables with exponents. If the function contains more variables, then the variable should be constant. So let's have our represented equation, a function of first degree, where fx equals to c, where x plus c 0, cn is not equal to 0. So let's move on our third type of function, quadratic function. Let's see the represented equation, where fx equals to ax squared plus bx plus c is not equal to 0, where a, b, and c are constant, and a is not equal to 0. Let's continue on our fourth type of function, rational function. So let's see our represented equation. quotient of two polynomials, where fx equals to gx over hx, and hx is not equal to 0. Example, fx equals to x plus 1 over x plus 3. So let's continue on our fifth type of function, power function, where fx equals to x raised to n, and where n is a real number. Example, fx equals to x raised to 5, where n is equal to 5. Let's continue on our sixth type of function, absolute value of function. An absolute value of function is a function that returns the distance of a number from 0. So let's see the represented equation, where fx is equal to the absolute value of x. Example, fx is equals to the absolute value of 7 is equal to the absolute value of 7 is equal to 7. So let's continue on our seventh type of function, polynomial function. Let's see the represented equation, where fx is equal to an x raised to n plus a n minus 1 and x raised to n minus 1 plus so on plus a1x plus a0. For example, fx is equal to 5x raised to 3 plus x squared plus 4x plus 10. Let's go on our eighth type of function, greatest integer function. Let's see the represented equation, where greatest integer of x is less than or equal to x, where fx is equals to the greatest integer of x. For example, fx is equals to the greatest integer of 1.15. Let's have our ninth type of function, piecewise function. Let's see the represented equation, where fx is equals to 1 if x is less than 1, 2 if 1 less than x and less than 3, 3 if x is greater than 3. For example, fx is equals to 4x plus 5, 3x minus 8. Let's have our final type of function, radical function, where fx is equals to the square root of fx. For example, fx is equals to the square root of 100.
Evaluation of functions. The function notation y is equals to f of x tells you that y is the function of x. There is a rule relating y to x such as y is 3x plus 1, or you can write it as f of x equals 3x plus 1. Think of y is equals to f of x such as way of saying y depends on x. It means there is a rule that tells you how to find y if you know x. For example, the rule might be multiply x by 3 and then add 1. This rule can be written as y is equal to 3x plus 1 or f of x equals 3x plus 1. Both ways say the same thing. Y is calculated from x by following the rule. How are we going to evaluate functions? To find f of x for a given value of x is to evaluate the function f by substituting the input value x into the equation. Or to find f of x for the specific number means you are figuring out what the function f does to that number. You take the number, put it where the x is in the function's equation, and then calculate the result. Up to this point, parentheses have been used to represent multiplication. In this function notation f of x, there is the different use of parentheses. F of x means the value of f at x. It does not mean f times x. Letter other than f such as g and h or g and h can be also used. F is the name of the function and f of x is the value of the function of x. Example, f of x is equal to 3x plus 1. Find f of x is equals to 1. So let's write f of x is equal to 3x and close and open parenthesis 1 plus 1 is equals to 4. Let's try other example. F of x is equals to 3x plus 1. Find x is equals to 2. Let's write f of x is equal to 3x close and open parenthesis 2 plus 1 is equals to 7. Another one, f of x is equal to 3x plus 1, find x is equal to 3. So let's write f of x is equal to 3 close and open parenthesis 3 plus 1 is equal to 10. So let's try this one. And let's see the answer.
Inverse function. In a function y is equals f of x, where x determines y, the inverse function is f negative 1 of x, where y determines x. In the function y is equals to f of x, the input x determines the output y. The inverse function, denoted by f negative 1 of x, reverses the relationship, allowing the output y to determine the output x. Essentially, the inverse function undoes the original function, providing a means to recover the initial input value from the output. Steps in finding the inverse of a function. The given below is f of x is equals 4x minus 7. Step 1. Replace f of x to y. It should be y is equals to 4x minus 7. Step 2. Interchange x and y. It should be x is equals to 4y minus 7. Step 3. Divide both sides by negative 4. It should be negative 4y over negative 4 equals negative x minus 7 over negative 4. The answer is y is equals to x plus 7 over 4.
Composition of functions. Composition of functions is another way of combining functions. This method of combining functions uses the output of one function as the input for a second function. In general, given functions f and g, the composite functions denoted by. Think of it like a chain reaction. You take the output of one function, known as f, and feed it into another function, known as g. It's like a game of telephone, where the result of f becomes the starting point for g. This combined process creates a new function, known as composite function, and it is often written as f of x or g of x.
For example, the given below is f of x is equals to 4x minus 5, and g of x is equals to x squared plus 4. Now, if you look right below the given, you will notice f and g in a parenthesis and an x besides it. So first, write the given equation for f of x and replace x by the value of g of x. So it will be 4 open parenthesis x squared plus 4 close parenthesis minus 5. After that, start by applying the distribution law for the given equation, so it should be 4x squared plus 16 minus 5. After that, combine like terms. The like terms for the given equation is 16 minus 5, so it should be positive 11. So the answer is 4x squared plus 11. Now that we have an idea about how to solve a composite function, let's try solving this one. F of x is equals to 2x minus 3 and g of x is equals to 2 minus 5x. For letter A, g times f and x. For letter B, g times f and replace the value of it by negative 2. For letter C, f times f and replace the value by positive 2. Are you guys done solving the equation? Now, let's all reveal the answer. The answer for letter A is negative 10x plus 17. And the answer for letter B is equals to 37. And lastly, the answer for letter C is negative 1. This is the end of the discussion for composition of functions. Let us now proceed to the next lesson. Hope you learned something in this lesson.